Algebra 2, Lesson 76, using both substitution and elimination and negative vectors. So we'll start off with substitution and elimination. What they really mean here is that they're going to start giving you 3 systems of linear equations instead of 2. So in the past, we've dealt with problems like this where we use substitution or elimination. Now what we're going to be dealing with are problems like this, where we now have not 1, not 2, but 3 equations. So we're going to have to use a combination of substitution and elimination to solve them. So let's go ahead and get these problems going on our work paper. Okay. So we look at these problems, and the first thing I want to look for is, can I eliminate anything out of these big long equations? I'm looking at it, and I mean, I might be able to eliminate the y. I'd have to do a pretty good amount of multiplication. But I do notice that this bottom equation, I can solve it for x. And then anywhere I see an x, I can replace it with a z. And if I can replace all the x's with z's, then instead of having 2 equations with 3 unknowns, I have 2 equations with 2 unknowns, which is something I'm more used to. So I'm going to start by solving for x. If I add 3z to each side, this will cancel, and then I get x equals 3z. So first equation. Now I'm going to take this, I'm going to substitute it into both of these equations. So I will rewrite this equation with 3z replacing all values of x. So this is going to become 2 times parentheses 3z plus 2y minus z equals 12. The bottom one is going to become 3 times parentheses 3z and parentheses minus y plus 2z equals 21. All right, not quite ready to use these yet. I'm going to have to do a little bit more simplification. This is going to become 6z minus z combines to become 5z. So I now have 5z plus 2y equals 12. Here I combine these two to become 9z. 9z combines with 2z to become 11z minus y equals 21. Here I'm going to look for the elimination. Again, earlier I said I thought I might be able to eliminate those y's. I can go ahead and do that now because it's a lot easier to look at. It's less terms I have to add and combine. So I'm going to take this equation. Since it has the opposite sign, I need to give it a coefficient of 2. So I'll multiply this entire equation by 2. That rewrites it to become 22z minus 2y equals 42. And then don't forget to multiply both sides of your equal sign. That's a commonly made mistake. And then I'll pull this equation from up top down here. 5z plus 2y equals 12. And I can now eliminate the y's. So I will add both of these equations to each other. The y's cancel. 22z plus 5z becomes 27z. 42 plus 12 becomes 54. I'm going to divide both sides by 27. And I will see that 27 goes into 54 exactly 2 times. So z is equal to 2. Now, if I know what z is equal to, I can then find out what x is equal to. So if z is equal to 2, substitute up here, x is then equal to 3 times 2, which is 6. So I've now got 2 answers. I've got 6, I've got 2. Last thing I need to find is y. Now I can substitute these numerical values into any of the good equations that I've created. I'll go ahead and underline those in black. So this is a good equation, this is a good equation, this is a good equation, this is a good equation. Any 4 of these equations I can substitute these numerical values into. Well, this is also a good equation, but I don't need it anymore. So these 4 equations I can substitute x or z into to get the answer for y. To make it simple, I think I'm going to go ahead and use this one, because then I can just move y to the other side, and I can rewrite this one pretty easily. So if I add y to each side, that would cancel, and then if I subtract 21 from each side, that's going to cancel, and what's going to happen is my equation will get rewritten as, I'll bring it down here, I'm going to get 11z minus 21 equals y. I can then substitute 2 for z, so 11 times 2 minus 21 equals y. 11 times 2 is 22. 22 minus 21 equals y. So 1 equals y. So now that I've got my 3 answers, I just have to write them in a ordered triplet. No, it wouldn't be an ordered pair. So into a coordinate, an x, y, z coordinate. So my final answer would be 6, 1, 2. And that's how I'm going to write it. Okay, so that's substitution and elimination being used at the same time. Let's go over now to negative vectors. Okay, so in order to understand negative vectors, let's recap what we know about positive vectors. So a positive vector has a direction given by degrees, and we know that this direction can either be positive or negative to indicate the same location. And then it has a magnitude or a length. In this case, we have a vector length 7 in the direction of 45 degrees, or we could say negative 215 degrees. So 2 ways to write this vector. Now, what we're talking about with negative vectors is kind of like the exact opposite. If you one way to think of a negative vector is an equal opposing force. So we have a force that's pulling away from origin at a strength of 7 in a direction of 45 degrees. The opposite force would bring us right back to origin. So the opposite force would go in the exact opposite direction at a force of negative 7, and then it's going to go in the opposite degrees. So if we were to represent that in positive degrees, what we'd have to do is we'd take 45 degrees, we would add 180 to give us 225 degrees for a positive angle. All right, so one way to write this negative vector is going to be negative 7 at an angle of 225 degrees. And then just like a positive vector, we can also write it using negative angles. So what we do here is we'd actually, again, add 180 to negative 215 or subtract it, depending on how you're viewing it. Excuse me. And that's going to bring us to a negative angle of 135 degrees. So the other way to write this negative vector is going to be negative 7 at an angle of negative 135 degrees. Excuse me. I found that when I make multiple videos in one day, my voice gets very dry, and it's hard to keep talking with a dry voice. It makes you cough. So now that we understand positive vector and we understand negative vector, let's talk about how this applies to our homework. And then we're also going to have to be able to apply this in adding vectors. Again, you can only add vectors in rectangular form, but first let's compute. Oh, actually not first, but what we'll be doing in this lesson is showing you how to compute negative vectors to find out what the actual positive vector is. Excuse me. So, if we're given a negative vector of negative 4 at a magnitude of negative 20 degrees, when we graph this, we have to realize that this negative vector is not what we're going to be adding. What we're actually going to be adding is the positive vector. So if we go at negative 20 degrees, that puts us in the 4th quadrant, and we're at a length of negative 4. The actual vector that we want to use is going to be the positive vector. So even though you can write a negative vector, the vector that's going to be computed is going to be the positive version. So we now have 4 ways of writing one vector. And then we know that this angle is also going to be 20 degrees. And this will be positive 4. So the vector we're dealing with is actually in the 2nd quadrant. It has a theta of 20 degrees, and it has a hypotenuse of 4. We have to figure out the r and the u. In this case, r will be positive, and the u will be negative. So we'll be using trig identities. In this case, the opposite of the angle is going to be r. So we'll be using sine to find opposite, and then we'll be using cosine to find the u. If you remember, the shortcut to this is to take the hypotenuse of, we'll do our computations in purple. Maybe we'll go with green. Yeah, we'll just stick with green. We'll take the hypotenuse and we'll multiply it by the sine of the angle, and that is going to equal r. And then we'll take the hypotenuse and we'll multiply it by the cosine of the angle, and that's going to equal u. So we go to our calculator. 4 sine 20 end parenthesis, and I get switch colors. I get 1.37 r, and then I'm going to get minus, because u is going to be a negative value. So we go 4 cosine 20 end parenthesis, and I get 3.76 for u. So minus 3.76 u. And I have successfully computed this negative vector. Once I do that, I can then add these rectangular coordinates to any other vector or any other rectangular coordinates to find the resultant force. If you have any questions, let me know on Moodle, and I will see you in class.